A house is so much more than just a roof over your head. It's actually this incredible, highly engineered machine that's built to fight a constant battle against gravity, wind, and especially water. So, how does it all come together? Well, we're going to find out. Let's start from the ground up. Okay, to really get a grip on the forces we're talking about, just picture this. A pretty modest 1,600 square foot roof has to shed over 1,000 gallons of water for every single inch of rain. 1,000 gallons. So yeah, you can see why I say a house is a machine. It's designed specifically to manage this constant, relentless battle with the elements. And you know what? That battle, it doesn't start when the walls go up. Oh no, it begins way, way before that. It starts with conquering the very ground the house is going to stand on. This is where a home gets its real strength, from the foundation. So what's a foundation really for? Well, it solves two massive problems. First, it literally lifts the house's wooden frame up and away from all that damaging moisture that's always in the soil. And second, it has to take the entire weight of the building, and I mean everything, what builders call the load, and transfer it safely down into the earth. Now, you can't just go pouring concrete. Builders have to do their homework first. They've got to assess the soil, right? Make sure it can actually hold the weight of a whole house. Then they establish the grade. And all that means is they make sure the ground slopes away from the house. It's the first and honestly one of the most critical steps in managing all that rainwater we mentioned earlier. Okay, so here's something amazing. How do you think builders get those corners perfectly? And I mean perfectly square. They use ancient math. No, seriously. They use a 2,500-year-old formula, the Pythagorean theorem. You remember that from school, right? A squared plus B squared equals C squared. Well, it's used every single day on construction sites to make sure the foundation is a perfect rectangle. And it has to be perfect, because if it's not, well, nothing that comes after it will be right. All right, so the foundation is solid. What's next? It's time to build the frame. The best way to think about this is it's the house's skeleton. This is the part that gives the building its shape, it's what defines all the rooms, and it provides pretty much all of its strength. And if the foundation's job is to fight water, the frame's job is to fight gravity. I mean, this is where that war is really fought. The whole frame is engineered to carry two different kinds of weight. You've got dead loads, that's just the weight of the house itself, but then you have live loads, and that's you, your furniture, snow piling up on the roof, even the force of the wind pushing against the walls. The whole system designed to carry all that weight safely to the ground, it's called the load path. So you might be surprised to learn that over 90% of modern homes are built using something called the platform frame method. And this was a huge innovation. The old way, called balloon framing, used these massive, long studs that ran all the way from the foundation clear up to the roof. As you can imagine, that was tricky. Building one story at a time on a solid platform is just so much safer and way more manageable. And this whole platform idea points to a kind of hidden genius in modern construction. There's the system called modular coordination, and it's all based on a simple 4-inch measurement, or module. Think about it. Why is a sheet of plywood 48 inches wide? It's so it fits perfectly over wall studs that are spaced either 16 or 24 inches apart. See, 16, 24, 48, they're all divisible by 4. The entire system is designed this way to minimize cutting, which means less waste and less labor. It's actually brilliant. So step 1 of framing, carpenters build the floor system right on top of the foundation. This creates that first strong, level platform. It's also their chance to correct any tiny imperfections from when the concrete was poured. You get a perfect base to build on. Okay, now you've got this perfectly flat deck to work on. So what does the crew do? They build the walls lying down. They assemble the whole thing on the floor, and then, once it's framed, they lift it up into place. This is that moment, It's when the house really starts to look like a house, and you can actually see the rooms for the very first time. And finally, step 3. The ceiling joists and the roof framing go on top. Now, this isn't just about getting ready for the roof. It's a really critical structural step. This is what literally locks all the walls together, completing that load path we talked about and turning the whole thing into one rigid, super strong skeleton. So the skeleton is done. Awesome. But it's completely exposed to the wind and rain. The next big challenge is giving it a protective skin to shield it from the elements. When it comes to framing a roof, you've basically got two main choices. On one hand, you have rafters. These are cut and built right on the job site, which gives you a ton of flexibility for cool things like cathedral ceilings. But on the other hand, if you're looking for speed and efficiency, you just can't beat factory-built trusses. A whole crew can install them in just a few hours. And that's exactly why about 2/3 of all new homes use them. It's easy to think a roof is just the shingles you see from the street, but it's not. It's actually a system of 3 layers working together. First, you have the sheathing. That's usually plywood or something similar that creates a solid deck. On top of that goes a water-resistant underlayment. And then come the shingles, which are the final layer that sheds the vast majority of the rain. For the roof to work, all 3 of those layers have to be installed perfectly.
Now, here's a really important detail. Most roof leaks, they don't happen out in the middle of a big open field of shingles. No way. They happen where the roof meets something else, like a wall, a chimney, or a vent pipe. These are the weak spots. And that's where metal flashing comes in. It's the perfect analogy. Think of it as a custom-made raincoat for the house, designed to channel water safely away from all those vulnerable seams.
So as you've probably figured out by now, controlling moisture, water, is one of the single biggest, most relentless challenges in building a house. And it's because water doesn't just attack from the sky, it attacks from all sides all the time. A good builder is basically fighting a war against water on 3 separate fronts. You've got the obvious one, rainwater, coming from the sky. But then you've got groundwater constantly pressing against the foundation from below. And then there's the sneaky one, invisible water vapor that's always trying to move right through the walls. So to fight that groundwater, foundations get a special protective coating. Your standard building code just requires what's called damp proofing. It's a basic moisture-resistant layer. But if you're building in a place with really wet soil or a high water table, you need to bring out the big guns, a much more robust, totally seamless waterproofing membrane. That's what it takes to really keep a basement dry in those conditions. And this just goes to show you that sometimes the simplest, lowest-tech solutions are the most effective. Building codes actually require that the finished ground, the grade, slopes down at least 6 inches over the first 10 feet away from the house. It's so simple, right? But it's an absolutely critical detail that just lets gravity do all the work of pulling water away from your foundation. So when you think about it, from the soil to the foundation, up through the frame, and out to the protective shell, it becomes really clear. A house isn't just a collection of lumber and nails and shingles. It's a single, integrated system where every single piece affects every other piece. There's a great quote that sums this all up perfectly. It says that quality work requires 2 things, forethought and the proper sequence of installation. And that's it, right there. It's not just about using good materials. It's about thinking ahead, anticipating problems, and understanding exactly how every part needs to fit together in the right order. Which kind of leaves us with one final thought. We always focus on the physical tools, don't we? The hammers, the saws, the nail guns. But what if the most important tool for building a house isn't any of those things? What if the most important tool is the plan? That forethought, the engineering, and all the knowledge that it takes to transform a pile of raw materials into a safe, strong, and durable home.